Hi all, this is Hydrosphere Revision Continued. I'm going to go through all of the physical features of drainage basins now, and I'm going to go through them quite rapidly. To be honest with you, there are actually dedicated videos on the website for each feature, so I'm going to try and give you a crash course in all of the features in an amount of time that is maybe a bit more easy for you to watch and to keep up with. Pause the video as you go along if you want to stop and take notes, or even try and watch a little bit of it and then reproduce it from memory and then rewatch it to see how correct you were. Okay, so we'll start off with a V-shaped valley. It does help to support your answer with some diagrams. A V-shaped valley is basically formed when a flat landscape with a river flowing through it. This is the flat landscape. That river is flowing out of the board at you, so we're looking at it in cross section. Gradually, the river erodes down through the flat landscape. This shaded area that I've drawn is the area that is going to get eroded away in the future. And ultimately, you're left with a steep-sided valley with a V-shaped cross-section, and as we look up the valley into the distance, the hills, the interlocking hills as they are known, of the V-shaped valley form. A visual way to understand this is if you interweb your knuckles like this. That's what looking down a V-shaped valley would look like, with each of my fingers being one of the interlocking hills of the valley, and the zigzag between my fingers being the winding course of the river as it's eroding its way down through the landscape. So how do we score these marks? Well, first of all, I'm going to talk about vertical erosion. Vertical erosion takes place by the river cutting down through the land. Okay? Vertical erosion cutting down through the land. I'm just going to do this in brief note form. You obviously would need to write fuller sentences. How does vertical erosion cut down through the land? First of all, by abrasion. Abrasion is when rocks in the water wear the land away. There's a second process by which vertical erosion cuts through the land, and that is hydraulic action. And that is when the repeated, that's important, the repeated pressure of gas and water being forced into cracks shatters the rock apart. Now, in the higher mark schemes, you're going to get a mark for abrasion, a mark for its definition, a mark for hydraulic action, a mark for its definition, and a mark here on vertical erosion. That's 5 marks right there. You would then go on to talk about interlocking spurs, and that's these features here. And they form as the river erodes down into the land. And material is eroded and washed downstream, and that explains how the landscape actually changes shape. The material is transported away. Okay, that's V-shaped valley in a nutshell. Let's move on. The next feature that you might need to explain is a meander. Now, when I revise meander, I tend to do meander alongside Oxbow Lake, and you'll see me do that right now. So a meander is basically where a straight section of a river that has deeper areas and therefore shallower areas begins to swing and turns into a shape similar to this. That shape has bends in it. Those bends have outside edges and they have inside edges. Now the inside edges, which I'll just colour in here, those are known as beaches, and the outside edges are known as cliffs. It is helpful to draw this diagram in cross section. If I just put the mark A and B here, you don't need to do this in your exam diagram, but it's useful for the explanation. If this is the line A to B, then A is here and B is there, and that line I've just drawn is the cross-section line that this diagram represents. So here is the beach, the build-up of deposition on the inside bend that I've drawn there, and here is the cliff on the outside bend of the meander. And this arrow represents the force of helicoidal flow, which is the spinning movement of the water that transports material from the outside bend to the inside bend to form the beach. So how do we start? Well, you've got riffles and pools. Riffles and pools. Well, the riffles and pools are shallow and deep. They have different speeds, and therefore the river swings. This little 3 dots in a triangle means therefore, by the way. So these are riffles. The shallow ones are riffles. The deep ones are called pools. Riffles are shallow, pools are deep. They therefore have different speeds, and because the water is forced to move at different speeds, it starts to wobble side to side, if you like, and that causes the river to swing. As it swings, it erodes using the process of abrasion. I'll start that again. As the swinging motion takes place, lateral erosion occurs. Just like in V-shaped valley where we had vertical erosion, lateral erosion is the opposite of vertical. It means side to side as opposed to up and down. So lateral erosion occurs. How does lateral erosion how does it actually cut through the landscape to create this sideways movement? Well, it uses abrasion and it uses hydraulic action. I'm not going to revise those terms again with you because I've just done so. So far, you're definitely scoring marks on riffles and pools causing the river to swing. You probably will get 1 for lateral erosion occurs, and definitely scoring 2 for each of the fully developed explanations of abrasion and hydraulic action. The outside bank is faster. Outside bend is fast. Therefore, erosion is greater. Therefore, a cliff forms. And obviously, the inside is the opposite. Inside bend is slow. Therefore, erosion is less. Therefore, a beach forms. Really quite straightforward. The last diagram refers to the process of helicoidal flow, and helicoidal flow is the spiraling rifle bullet-like movement of the water as it flows down the river, which transports material from the outside bend to the inside bend and helps to construct the river beach. Great, let's move on to Oxbow Lake. Oxbow Lake relies upon the processes behind meander formation, of course. So typically you would start off with your meander. In diagram 2, you're going to have a meander that has eroded laterally eroded to the extent that 2 outside bends are touching at what we call a neck. And that neck is then broken in a flood event, leaving a stranded lake and a new straight river course. I would refer to lateral erosion. I would refer to abrasion and hydraulic action. I would refer to the outside bends being faster, eroding more, and forming cliffs. I would refer to two cliffs meet and form a neck. Okay, now these first 3 points I've gone through much faster because I've just gone through them in the previous answer. Here, this abrasion and hydraulic action causing the outside bends to erode into cliffs. When those two cliffs meet, you get this formation here, which is known as a neck. A neck. A flood breaks the neck. The oxbow is stranded and a new channel is formed. The oxbow eventually dries up. And that's Oxbow Lake. Quite frankly, I think these questions are really quite easy, but they're only easy if you've mastered these first 3. Get these first 3 right, and then really you can take your pick of what the remaining sentences are that you're going to try and remember. But as long as you know abrasion and hydraulic action fully and in detail, and you understand that they are part of a sideways erosive force known as lateral erosion, and that causes the outside bends to meet to form a neck through the formation of cliffs, then you're well on your way to a very strong pass in this question. Okay, last one is waterfall. Waterfall is when the river is travelling over the land, and the land is made of 2 different rock types, hard rock and a softer rock type. Here's the river flowing over the land. The river will erode the soft rock faster, so this happens. A step occurs, known as a nick point, by the way. The river will not stop eroding the soft rock, though. It will continue to erode the soft rock away and then gradually erode underneath the hard rock. So in diagram 3, you're left with this kind of scenario. Here's your hard rock, here's your soft rock, and here's the river. As the river falls down, it undercuts the hard rock. This area of hard rock will collapse and fall into the river and cause the waterfall to retreat. This deep scooped out part here is called a plunge pool, and that's eroded by all the swirling fragments of hard rock that fall down into here. So where do we start? Well, just like V-shaped valley had vertical erosion, meander and Oxbow Lake had lateral erosion, here we have differential erosion. Differential erosion, just like the differential in your car, is when something is happening at 2 different speeds. So differential erosion is when the soft rock is eroded away faster than the hard rock. You would need to give a full definition of differential erosion to score the mark. How does differential erosion affect the land? Well, it does it through abrasion and, you guessed it, hydraulic action. Quick reminder, for a full definition of the first erosive process, you'll get 1 mark. How does this erosive process actually attack the land? There are 2 marks available for each. After this point, you would point out that the hard rock is undercut, unsupported, and collapses. The fragments of rock erode a plunge pool, and the waterfall retreats upstream. really quite straightforward when it's laid out that rapidly to you, I feel. The waterfall does stand on its own, I suppose, as a slightly distinct answer because it does have some terminology that are unique, but not really a huge amount of extra learning. Play a little bit clever with your revision time on this, people. Don't spend hours trying to word perfectly remember every single physical feature. You know, you're going to score good marks if you have a really top-notch understanding of abrasion and hydraulic action, and you have a broad understanding of the general physical processes at play. You're going to do fine. If you want 8 out of 8, sure, you're going to have to put in a little bit more, bit more work, but to score acceptable, high, good, solid marks in these relatively easy, straightforward questions, don't break your back over it. Instead, spend a little bit more time remembering and revising questions like this, which can catch you out and require a bit more thought. And the only question that I've not covered is the movement of water through a drainage basin. But I am not going to do that in this sequence of videos because I have actually covered that revision via the videos on hydrographs. So if you're wondering where that is, go back to the hydrograph video and look at the reasons for, look at the keywords for why water moves around drainage basins in the way they do. Okay, I hope you found that helpful, everybody, and good luck with your revision this week. I want to see the tasks that you've been set done. You know, make sure you do them well, please, and make sure that you make good use of the time that you're going to spend revising. All right. Take care. I hope you're all well.